Hello everyone. What we'd like to do in this video here is get practice on deciding when to use the law of sines and when to use the law of cosines. I have two triangles up here. Okay, so these are drawn to scale. I mean, they're not perfect, but think that these are the triangles. They have these general shapes. Okay, and what I want you to do is for this first triangle, I want you to try to find this length x. For the second triangle, I want you to try to find this angle theta. Go ahead and pause the video. Do I need to use the law of sines? Do I need to use the law of cosines? Do I need to think about what my answers are? Give it a shot. Okay, let's do it. For this first one here, let's think. Well, if you have things memorized, which I don't, I mean, the only reason I may have this memorized is because, well, I've been teaching this for the last couple days, so it's fresh in my mind, but a couple quarters from now, will I have this memorized? Probably not. But this is a side angle side. This is a side angle side triangle. So if you're really into memorizing things, you might say, oh, this is the situation to use the law of cosines. Now, I don't know, do I do that typically? No. I'm going to think here, is it possible? I mean, the law of sines has a simpler formula. Is it easy? Can I use the law of sines here? Well, x, I'd have to do x over the sine of 40 degrees. And that would have to be equal to what? This would have to be 18 over the sine of this angle. I don't know that angle. Or I'd have to do 10 over the sine of this angle. I don't know that angle. Law of sines is not going to help us here. We have to use the law of cosines. Okay, so let's see what the law of cosines will say. It'll say that this x squared is going to be equal to, it's going to be this, it doesn't matter which order you do these in, but 10 squared plus 18 squared minus a 2 times a 10 times an 18 times the cosine of 40 degrees. Okay, let's go ahead and plug this into our calculator. So we have 10 squared plus 18 squared minus 2 times 10 times 18 times the cosine of 40 degrees. So I'm getting that x squared is roughly 148.224. I'm going to leave the exact answer I have in my calculator. To figure out what this is, I'm just going to raise that to the power of 0.5. It's the same thing as taking the square root. So here we have that x is approximately 12.175 if we're rounding to 3 decimal places. And that's the answer, law of cosines problem. Okay. Let's go ahead and erase what we have here. Let's do the next one. This is the answer to this problem. Okay. Let's do this one. All right. So oftentimes I'm going to see if I can use the law of sines first because it's a simpler formula. And in this case, we can use the law of sines. Here I have the sine of theta over 10 would be equal to the sine of 40 degrees. Maybe I should put a degree sign here. Degrees all over 8. Okay. Notice if you try. Notice that we cannot use the law of cosines. We can solve for theta, but we couldn't use the law of cosines even if you tried to use it. I would need to know all three sides here. So if I had to know what this angle is, well, I'd have to set up what? I'd have to set up 10 squared would be equal to, well, 8 squared plus, I don't know what this side is squared, minus a 2 times an 8 times a, I don't know, times the cosine of the angle. There's too many unknowns here. The law of cosines is not going to help us here. We've got to use the law of sines. Okay. But now notice we're using the law of sines to find an angle, so we got to be careful. Also notice this is an S triangle, or PG version. SSA triangle. You got to be careful with triangles, or you know what I mean. Be careful. We're using a sine to solve an angle. Okay, so sine of theta will be equal to 10 times the sine of 40 degrees all over 8. Okay, so let's see what we get here. So this will be. Let's just do the sine inverse of this. We'll just do it in one fell swoop. Theta will be equal to the sine inverse sine inverse of 10 times the sine of 40 degrees all over 8. Let's see what we get. The sine inverse of 10 times the sine of 40 divided by 8. So here this is saying that theta is equal to 53.464 degrees. Let's think about whether this makes sense. Okay. Notice that this is an acute angle. The picture that we drew here is the obtuse angle. This is not the correct angle that we're looking for. So what we have to realize is remember when we're drawing the unit circle, I guess if we want to figure out what is this here? What is this value? What's 10? What's 10 times the sine of 40 divided by 8? So this is 0.803 roughly. Okay, so we're on the unit circle. I want to know when we have a height of 0.803. Okay, well, when I do sine inverse, sine inverse only spits out angles between negative 90 and 90, so of course it's going to tell you the acute angle. But that's not the one we want. We have to mentally think about how to get the other one. Different color. We want this angle. We want the obtuse angle. So to figure out the angle that we want, it's not this one. I'm going to call this one. We're going to call this one. I don't know. Well, what do we call this? We'll call this one phi. This is not the right one. This is not the angle that we want. Okay? So what the angle that we do want is we want theta would be equal to 180. I need to take 180. This is phi. This is the one that the sine inverse told us to get theta, which is the obtuse angle. We need to take 180 and subtract phi. So 53.464 degrees, 180 minus 53.464. So we should have that the angle we're really looking for is 126.536 degrees. This is the answer. So whenever you're using sine to find an angle, you got to be careful because it's only going to tell you the possible acute one. You need to make sure to look at the unit circle to think about how to get the obtuse one and consider the obtuse angle. In this case, we wanted the obtuse one. All right, let's do 2 more. We'll put 2 more up on the board. I can try those. Okay, so let's say we have let's say that this is 25 degrees. Let's say that this here is 98 degrees. Let's say this length here is 1,000, and let's say that this length here is x. Let's put one more up on the board. Let's say this is 10, this is 11, this is theta, and this is 4. Okay, so I have 2 triangles up here. For this first one, I want you to find the side length x. For the second one, I want you to find angle theta. Go ahead and pause the video and give this a shot. Okay, let's do it. So let's think about this first one. What can we do on this first one? Well, the first thing I'm going to notice is that I know 2 of these angles. I could find the third one, but let's say you don't find the third one quite yet. What if you tried to use the law of sines? Well, you could say x over the sine of 98 degrees. Well, that could be equal to 1,000 all over the sine of this angle. So I would need to at least know, I would need to know this angle to use the law of sines, but we can easily figure out this angle because I know two of them. So I think that's the route I'm going to take. And notice we're finding a side and not an angle, so I'm not too worried about using the law of sines here. So let's find this angle. So let's do it up here. Give ourselves some room down here. This angle here, this will be 180 degrees minus 98 degrees minus 25 degrees. So degrees. Okay, so let's see what we get. So 180 minus 98 minus 25, getting 57. So this angle here is, doing a different color, 57 degrees. 57 degrees. Okay. So we'll put a 57 right here. 57 degrees. So x, I'm going to multiply both sides by the sine of 98 degrees. X is going to be the sine of 98 degrees times 1,000 all over the sine of 57 degrees. So let's see what we get. So the sine of 98 times 1,000 divided by the sine of 57. So I'm getting that x is 1,180.75 now. If I'm rounding to 3 decimal places. So this is x. Cool. All right, let's do this next one. Okay. Need to find theta here. Okay. I have to use the law of cosines here. I don't know any of the angles, so I can't use the law of sines with no angles. So I have to find an angle first. This is an SSS triangle. I gotta use the law of cosines. So let's see here. What would the law of cosines say? So I gotta think about the side that's opposite to it. So it's gonna say that 4 squared is gonna be equal to 10 squared plus 11 squared minus a 2 times 10 times 11 times the cosine of theta. So we have to use the law of cosines here. So let's see. So cosine of theta is going to be equal to 4 squared minus 10 squared minus 11 squared all over a negative 2 times 10 times 11. Of course, we could just take the cosine inverse of both sides. I'm not worried when using cosine inverse to find angles. I'm only worried when using sine inverse to find angles. So let's see what we get. The cosine inverse of 4 squared minus 10 squared minus 11 squared. Okay, divided by a negative 2 times a 10 times an 11. So I'm getting that theta. Theta here is 21 point, looks like 280. 280 if we're rounding to 3 decimal places. And this is degrees, it's an angle. So there we have it. So that's how I handle these type of problems. I'm usually don't have memorized, this is an ASA triangle, use this one, use this SSS triangle, use this formula. I'm oftentimes just looking at the pieces that were given to us. I usually try to use the law of sines first because it's a little bit simpler to work with. Usually I can quickly realize it's not going to work, and then I'm going to use the law of cosines. And if I start using the law of cosines to find angles, I'm going to continue to use the law of cosines to find an angle. So we found out what this angle theta was here. You could use the law of sines to find the other angles. Just continue to use the law of cosines here, so you don't make that mistake of when using sine inverse. You have to think about the acute and the obtuse angle. So just be careful. Okay, so this is we're finished with exploring the law of sines and the law of cosines. We'll see you in the next one. Take care.